Okay, class, this is Chapter 5, Section 4 on polynomials. A polynomial is simply a single term or a sum of terms in which all of the variables have whole number exponents. No variables appear in a denominator. Some examples of polynomials are 2x plus 7, 3x squared minus 5x plus 7, negative 2m cubed, and then the final one that you see there. You can see they go from very short, negative 2m cubed is a very short polynomial, 2m to the fourth plus 3m cubed n cubed minus 8m squared n to the fourth plus 4m n to the fifth minus 7, very long polynomial. They don't have the same number of terms, but remember the definition says a single term or a sum of terms in which all the variables have whole number exponents. All of these do have whole number exponents. So 2x plus 7 is a polynomial in x. 7 is called the constant term because there's no variable in it. It's just a constant number 7. It's always going to be 7. 2x, that term, could have any value because we don't know what the value of x is. So that's a variable term. 7 is a constant term. 3x squared minus 5x plus 7 is written in descending order of powers. That means my x's, I have x to the second power or squared here, x to the first power here, and no x there. And if you remember from today's lesson, no x could have come from x to the 0 power, meaning your x is descended from 2 to 1 to 0. We don't write x to the 0 power there because x to the 0 power is 1, and therefore we don't need it. So that's written in descending order of powers. 3x squared is the lead term, and 3 is the leading coefficient. The next one, 2m to the fourth plus 3m cubed n cubed minus 8m squared n to the fourth plus 4m n to the fifth minus 7, is also written in descending order of powers, this time of m, and ascending order of powers of n. If you look at my m's, I go m to the fourth, m cubed, m squared, m, no m at all. I descended the m's. Basically, the rule in math is to descend your order of powers by the first one alphabetically. In other words, on this problem, m comes before n, so you would automatically descend your m's, and oftentimes your second variable will ascend. Not always. What the second variable does not matter as much as what the first variable does. We want the m descending. Okay, the next couple are monomials. 3xy cubed is a monomial because it's not separated by a plus or a minus sign. There's no second term. A polynomial in one term is called a monomial. 2m squared np to the fourth, again, that's a monomial because it's only one term. It's not separated by plus or minus sign. There's one term there. One term polynomial is a monomial. Next, we're going on to binomials. You notice this has a plus sign in the middle, so that means I have two terms, thus a binomial. 3xy cubed plus 2x squared y squared, two terms, a binomial. Here I have a minus sign in the middle. That's separating my terms. The first term is 8m to the fourth n. The second term is negative 6m cubed n squared. Two terms, it's a binomial. So now I guess you have figured out that a trinomial would have three terms. And it has three terms because I have a plus and a minus there separating my terms. 3xy cubed plus 2x squared y squared minus 4x cubed y cubed is a trinomial with three separate terms in it. Okay, we're going to go on to the degree of a term. The degree of a term of a polynomial in one variable is the value of the exponent on the variable. If a polynomial is in more than one variable, the degree of a term is the sum of the exponents on the variables. So the degree of a non-zero constant is 0 because there is no variable raised to a power, so the degree is 0. So we want to look at these next couple and see what our degrees are. That's a one-term polynomial or a monomial. It's in one variable, so the degree is the power on that variable, meaning the degree is 3. The next one, 7, is a constant term. We said just a minute ago when we were defining it that the degree of a constant term is 0, so the degree of that monomial is 0. Negative 2m cubed n to the fifth p to the seventh This time I have three separate variables in there. The rule says the degree of that monomial is the sum of the exponents. So 3 plus 5 is 8, plus 7 is 15. The degree of that monomial is 15. The next one, 8st cubed. Again, I've got two variables in here, so I add their exponents. Don't forget, when there's no exponent showing, it's understood to be 1. That's s to the first power, t cubed. So the degree of that monomial is 4. Okay, you want to try those next couple on your own. We'll go over them in class next time. Degree of a polynomial. Remember, a polynomial can have any number of terms. It doesn't have to have one. A polynomial in one term is a monomial. Polynomial in two terms is a binomial. Polynomial in three terms is a trinomial. And after that we say 4-term, 5-term, 6-term polynomial, depending on how many terms it has. So the next one is 3x squared y cubed plus 4xy to the fifth. And we want to describe that by its degree and by its number of terms. So in order to determine the degree of the polynomial, first I have to figure out the degree of each term. This first term has a degree of 5. I added up the powers. The second term has a degree of 6. Again, I added up those powers. And it says for the degree of a polynomial, it's the same as the highest degree of any of the terms. So I look at those two numbers, I say which one is higher. It's 6, so the degree of that polynomial is 6, and it is a binomial because it has two terms. They asked us to describe it by its degree, that's 6, and by its number of terms, that's a binomial. This time let's start out with a number of terms. I have a minus sign here and a plus sign here, so I've separated it twice. That means I have 1, 2, 3 terms. A 3-term polynomial is a trinomial. Okay, now I want to figure out what the degree of each term of that polynomial is. So I'm going to add up those exponents. I have an understood 1 and a 2 and a 6. 6 and 2 is 8 and 1 is 9. The degree of the first term is 9. Here I have a 7, a 3, and a 2. 7 and 3 is 10 and 2 is 12. The degree of that term is 12. Remember, I'm determining the degree of each term individually. So now my last term is 2 plus 6 is 8, plus 3 is 11. The degree of that term is 11. So if you remember the rule, the degree of that polynomial is going to be 12 because I chose the largest of those three numbers. I don't add them up. I find the degree of each individual term and then I choose the largest number. So the degree of that polynomial is 12. You want to try those next three yourself and then bring your answers to class, and we will go over them on Monday. Be sure to watch the next part of this lesson on Chapter 5, Section 4.